Questions 11 through 20 on the 2018 Grade 11 Fermat Math Contest. A bag contains 8 red, a number of white balls, and no other balls. If 5 over 6 of the balls in the bag are white, then the number of white balls in the bag is. So I have 8 of the red balls and a certain number of white balls. So 5 over 6 represents the fraction of white balls. So it would be W plus 8, where 8 is the number of red balls. So cross multiply and you get 6W is equal to 5W plus 40, and therefore W is equal to 40. So there's 40 white balls. Number 11, the answer is C. In the given 5x5 grid, how many squares can be formed using the grid lines? How many of these squares contain the shaded 1x1 square? Well, let's look at it from the perspective of what is the size of the square. There's a 1x1, 2x2, 3x3, 4x4, and I think the largest we can make is a 5x5. Well, 1x1, there's only one, so that's the only square that would contain it. So we put a 1 here. 2x2, well, you can have this, this, and this. Those would be the 4. 3x3, this one, that one, that's 2, and then 3, and then this one, 4. So those 4. 4x4, this big one here, this one, and then this one, and then finally this one. So that's 4. And then 5x5 is just the entire square like that. So that's 1. So if you add up these guys, you get 14. So number 12, the answer is E. A digital clock shows the time 4, 5, 6. How many minutes will pass until the clock next shows a time in which all the digits are consecutive and are in increasing order? All right, well, I just used the answer choices. And when I added 458 minutes to 456, I got 1234. And that is indeed in consecutive order and increasing order. And since they want the next one, the only ones we need to really worry about are something less than 458 minutes. So we can cross out these guys. And when you add 376 or 315 to 456, you will not get digits that are consecutive and in increasing order. So number 13, the answer is A. The line with equation y equals x is translated 3 units to the right and 2 units down. What is the y-intercept of the resulting line? So we've got, let's say, this line right here. And we've got the line y equals x. So obviously that's the one that goes right through like that. Then we're taking this and translating 3 units to the right. So approximately, let's say here. 3 units to the right, so that is 3. And since we just translated that, it basically goes to the equation y is equal to x minus 3. So this time when x is 3, y is 0. And then you're taking this equation and then making another translation 2 units down. So approximately like that. So that equation, since y is going down by 2, it would be y plus 2 is equal to x minus 3. And they're saying, what is the y-intercept of the resulting line? The y-intercept is when x is 0. So that becomes y plus 2 is 0 minus 3. So y is equal to minus 5. And that would be about right there. So number 14, the answer is C. Francesca put the integers 1 through 9 in the 9 squares in the grid. She put one integer in each square and used no integer twice. She calculated the product of the 3 integers in each row and wrote the products to the right of the corresponding rows. She calculated the product of the integers in each column and wrote the products below the corresponding columns. Finally, she erased the integers from the 9 squares. Which integer was in the square marked n. Okay, so we got to fiddle around with this. Well, 21 is 3 times 7, right? So 3 and 7 obviously have to go here, but we have to have 3 numbers, so I'll tag on the 1. I think that would work. And then 108, I think the numbers that will work are 2, 6, and 9 in some order. And then the remaining numbers are 4, 5, and 8, and they match perfectly to the 160, 4 times 5 times 8. So we know, for example, that 1, 3, and 7 go here, but we don't know the order. We don't know where the 1 goes. Does it go here? Does it go here or here? That kind of thing. So then we have to concentrate on these guys. Okay, so how do I get 48? I can get 48 by putting a 1 here, a 6 here, and an 8 here. So 1, 6, and the 8. Now, just to be sure, I've concluded that n is 6, but just to be sure, let's just fill in everything else. To get the 135, I can get that by putting a 3, a 9, and a 5. The 5 is pretty easy to understand because that's got to be divisible by 5, and then the 9 and the 3. And then the only numbers left are the 7, 2, and the 4, and when you multiply them, you indeed get 56. So this is the perfect, or this is the complete way of filling out this square. So n is 6, and therefore number 15, the answer is D. Points P and Q are 2 distinct points in the xy plane. In how many different places in the xy plane can a third point R be placed so that PQ equals QR equals PR? We have a xy plane, and then we've got 2 points P and Q. Now, I have no idea where they are, so I'll just experiment. Let's just say here, P and Q. Now, we want a third point R so that we basically make this equilateral triangle. Well, I think if I put an R here, I could do that. This would most likely be an equilateral triangle. But I think if I put the R up here, it would also be the same. So I think the answer is 2, but let's just see if that holds true in another scenario. Let's put the Q in another quadrant. So let's say the Q is here and see what happens. Well, I think the answer would be pretty much the same, because if an R is placed here, I can make an equilateral triangle. And if an R is placed here, I can make an equilateral triangle. So as you can see, when you experiment, you see that there's really only 2 ways of placing the R. So number 16, the answer is C. In the diagram, square PQRS has side length 2. Points M and N are the midpoints of SR and RQ respectively. What is cos of MPN? Well, on the Canadian exams, you're allowed to use a calculator. So let's use a calculator. Why not? Side length 2, if M is the midpoint, SM would be 1. So this angle in here I'll call theta. So using the tan of theta, it would be 1 over 2. Use your calculator and you will get theta equal to 26.565. Now, because of the symmetry of this diagram, that's 2 and that's 1. Therefore, this is theta also. So therefore, this angle in here, we can just call it, well, it's MPN. Angle MPN is really 90 minus 2 theta. And since we know theta, we can calculate that. It will be 36.87. And then now you just take your calculator and calculate 36.87 cos, and when you do, you get 0.8. And that's 4 over 5. So 17, the answer is 8. Suppose that m and n are positive integers with the square root of 7 plus the square root of 48 equal to m plus root n. What is the value of m squared plus n squared? Well, I just did this the non-fancy way. I just figured out what is this on my calculator. This is equal to 3.732. Now, this looked very familiar to me because it's 2 plus 1.732. And those of you who have been doing math for a long time will recognize this to be root 3. So that is m plus root n. And that's really all there is to it. So that means m is 2 and n is 3. So m squared plus n squared would be 2 squared plus 3 squared, and that is 4 plus 9, which is 13. So number 18, the answer is E. Radford and Peter ran a race during which they both ran at constant speed. Radford began the race 30 meters ahead of Peter. After 3 minutes, Peter was 18 meters ahead of Radford. Peter won the race exactly 7 minutes after it began. How far from the finish line was Radford when Peter won? Well, let's draw some lines here. I think 3 lines should be sufficient, if you even need 3 lines. Okay, so now let's label this now. Peter and Radford, when they first begin, Peter is 30 meters behind, or Radford is 30 meters ahead. So that is the first part. Then the next part is at the 3-minute point. They say that Peter has caught up and he's now somewhat ahead. So if Peter is here, let's say Radford is here, and the difference between them is 18. And then at the 7-minute point is, I guess, the finish for Peter. And obviously Radford is at some point, and we'll just call that Y, and that's what we're trying to figure out. So this is 30, this is 30, and then we actually don't know this distance here from there to there. So I'll just call it D, if I even need it. Okay, so now let's talk about this. When this happens, by the time Radford gets to here and Peter gets to here, the time is the same. So speed is equal to distance over time, and time is equal to distance over speed. So the time for Peter is equal to the time for Radford when they are both in those spots, and that is at 3 minutes. So using this formula right here, what is the TP? It would be the distance. So Peter, for Peter, it'd be all the way from the beginning. So we actually haven't labeled this, so I'll label that X. So it would be 30 plus 18, 30 plus X plus 18, I should say, all over the speed for Peter. And then the time for Radford, well, he's only going from here to here, so that's just X for the distance, and then the speed for Radford, and that is equal to 3 minutes, that is. So from this equation, we can just get that X is equal to 3SR, and then we can plug that in to this one. So from that one, 30 plus X plus 18 is equal to 3SP, if you cross multiply with the 3. And then we can substitute for X. This is just going to be 48 plus 3SR is equal to 3SP. And divide through by 3 and you'll get 16 plus SR is equal to SP. Okay. Now we have to take into consideration the 7-minute scenario. So at 7 minutes, again, the TP will equal the TR, and that equals 7. TP in this case, distance over speed, so that's going to be 30 plus D plus Y, and over the speed of P. TR is the distance, which is just D, over the speed of R, and that is equal to 7. All right, so now we got to figure this out here. Well, using this cross multiplication, we get D is equal to 7SR, I should say. And then from this one, we can get that 30 plus D plus Y is equal to 7SP. Well, I can substitute that D is equal to 7SR. Like that, and then let's keep the Y, and then the 7 times SP, but SP is 16 plus SR, so I'll substitute that in like that, and this becomes 30 plus 7SR plus Y, and then when I expand that, I get 7 times 16, which is 112 plus 7SR. Okay, well, the 7SRs in a very nice way cancel out, so Y is equal to 112 minus 30, and that means Y is equal to 82. So 82 is the distance that Radford is behind Peter when Peter wins the race, because that is what Y represents. So number 19, the answer is D. For how many positive integers is x minus 2 times x minus 4 times x minus 6 x minus 2016, x minus 2018 less than or equal to 0? Okay, so let's talk about this. I think it will be easier if I go from the opposite direction. So what I mean by that is going in this direction. So what I'll do is I'll write out a few of them. I don't think I'll need too many, but just a few of them in that. Okay, let's talk about this now. X, the only thing they tell us that it's positive, right? So it starts obviously at 1, 2, and so on, but where does it end? They don't give us a boundary. So let's start with 2019. Let's see what happens. If X is 2019, every single one of these terms is going to be positive, and therefore the whole product will be positive, and therefore it will not be less than or equal to 0. And that also is true for anything greater than 2019, 2020, 2021. Okay, so obviously we've got to go smaller. When X is 2018, well, that becomes 0. So it definitely will be equal to 0, that entire product. So let's circle that, because we're going to keep those circled values. 2017. Now we get into the interesting stuff. When X is 2017, this expression is negative, but then everything else will be positive, right? That will be 1, that will be 3, and that will be 5, and so on. So we only have one negative, and therefore the whole expression will indeed be less than 0. Let's try 2016. Well, it's 2016, this becomes 0, so the whole thing becomes 0. So we're keeping these. Let's try 2015. When it's 2015, this will be negative and that will be negative, but everything else will be positive. So we'll have two negatives, negative times negative, but that is a positive. So that is not less than or equal to 0. So that we cross that out. Let's keep going here. 2014. When it's 2014, this is 0. So that expression will definitely become 0. Now 2013. When X is 2013, everything on this side will be positive, but we will get three negatives. This will be negative, this will be negative, and this will be negative. So three negatives, negative, negative, and negative, is negative. So it will also be less than 0. So that's good. 2012. Well, 2012, that becomes 0. So the whole expression becomes 0. And then now let's see what 2011 is. Hopefully there's a pattern here. When it's 2011, everything here will be positive, but then you'll have negative, 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 negative. 4 negatives will be equal to positive. So as you can see, that becomes positive, so we cross that out. So it looks to me, and you can continue this pattern, that it looks like we are starting with 2018 and then going backwards all the way eventually to 1, ... right? And it looks like every 3, and then we skip 1. So every 3, and then we don't use that. Then every 3, and then we don't use that, and so on. So our task now is to figure out how many that is. Well, it looks like in every set of 4, you use 3. So let's see if 2018 is divisible by 4. If it is, it makes our life easy. And unfortunately, it's not. Okay, no problem. We just have to figure out what is divisible by 4 near 2018. 2016, I think, is divisible by 4. And that's 504. So that means for every set of 4, you'll get 3. And there's 504 sets of 4. So for each of those, you'll get 3 that will make this expression less than or equal to 0. Okay? So that is 512. But then remember, I only did this for 2016. You have to do it for 2018. When you do it for 2018, you'll find that essentially what's happening is when you get all the way down to 1, it will be like this, where you will have 2 left, and those 2 are these guys. As you can see, for example, if I had continued this list all the way down, you'll see that these 4 give you 3 that work, these 4 give you 3, and then you have these guys left over. So you have to add those 2 that are left over to this 1512, and when you do, you get 1514. So that is the answer to number 20, which is C.